Hello, YouTube. This is UMills03. We're now on to lesson 8 of the Python curriculum, and we've been talking a lot about basically a lot of the fundamental structures and data types that are really critical and important for understanding in Python. And in the most recent video, in the last lesson, we talked about the if and the else if logic, right? And we talked a little bit more about Boolean variables. And we said basically, just like we can assign ints and floats and strings to variables, we can also assign Boolean expressions, true and false values, to variables. And so I think we had some of those in the previous lesson. And then what we did is we said, well, we can formulate an if-else if, right? And so essentially we have different architectures here. But if you just have a basic if statement, then the code here will run if and only if this Boolean is true. And so basically this is an example of independent if statements, where we would basically just be looking at these true or false statements one at a time, and then we would just run or not run each of the print statements depending on whether the corresponding Boolean was true. But then we said we could also have something called an if-else. And so what an if-else does is it runs a certain section of code if a particular Boolean is true, and it runs a different section of code if that Boolean is not true. So therefore you'd be getting exactly one output. In this example, you'd either be getting happy or sad. And since Miranda occurs after egg in the dictionary, since the M comes after the E, we would be expecting to print happy. We also talked about an if and else if, right? So now if you have else ifs, basically these are follow-up Booleans to check if the first Boolean that you started with is not true, okay? So the only way that any of these else if Booleans are even evaluated is if the first Boolean fails. So if the first Boolean is true, you just run the first block of code. But then if the first Boolean fails, if it's false, you can go ahead and look at these else if statements one at a time, okay? And so these would just be evaluated one at a time. And then basically once you link onto one of them, you would print that section of code, and then you would jump out of that if else if block. And so else is just a way of absolutely guaranteeing that some code will be printed even if the Booleans that we were checking for were not true. Okay, so we would evaluate, and we were talking about the architecture there, and hopefully it's kind of clear to you with what's going on with all of that. What we're going to be doing in this lesson is we're going to be talking about lists. In the Java curriculum, what we did is we studied something called an array, and it didn't come until about lesson 15. And so basically the ordering of topics in my Python curriculum and Java curriculum is not going to line up perfectly, okay? I might be talking about lists and functions and things in a slightly different order between the two languages, depending on what I think makes the most sense. But anyway, what we're going to do is we're going to learn about a list, okay? And lists basically acts like array lists in Java. Okay, so we're going to be talking about a dynamic array. We're going to be talking about basically a data structure, and it's still going to have square brackets, which is basically what it looks like in Java, but there are going to be differences. Okay, so a list in Python, basically that's like your basic data structure, kind of like your array is your basic data structure in Java. The similarity is that they both have square brackets, but there are a lot of differences. So the array is not resizable. A list is, okay? An array can only have one data type in it. A list in Python can have as many, you can mix and match data types in a list. But anyway, and without blabbering on too much longer than 3.5 minutes, let's go ahead and write some code. So go ahead and review the if-else if that architecture is not clear to you, but let's go ahead and think about a list. So what we're gonna do is we're gonna say a list is a data structure that is capable of holding multiple elements, okay? Conveniently, in Python, the elements do not have to be the same data type. So you can basically try to compare and contrast these two languages, right? Java is very data type heavy and data type strict, right? And they want to know, oh, is this variable an int? Is it a string? Python has ints and floats and strings, but it's really nowhere near as uptight about thinking about data types and declaring what data type a variable is, right? Python doesn't give anywhere near as much of a damn. So if you say conveniently in Python, the elements do not have to be the same data type, and then also what you would do is you would say a list in Python is much like an array list in Java. So I don't know how much background in Java you guys already have, but if you went through my curriculum, we've been studying so we're talking about a dynamic array. So the list can change size after it's been created. And so what we're going to do is we can say that lists store items They're going to be enclosed by square brackets, and there's going to be commas separating the items. Okay, so basically, it's enclosed in square brackets, and we will have commas separating the items. Okay, and basically, what we can do is we can access elements in the list by referencing the index positions within the list. One of the things you might have seen in computer programming before is that in many programming languages, including Python, we say that the first element in a list has index position 0, right? So if you were essentially looking at a list where you had 8, 2, 3, 4, basically we would say the 4 has index position 3, okay? And the 2 has index position 1. So hopefully that makes sense to you how that works. But how we're going to go ahead and create a list in Python is we're just going to give it a name. So we could go ahead and call it whatever we want. We could go ahead and call it group. Okay, and then we can just go ahead and give it some values. So we can go ahead and say 3, 8, 2, 1. Okay, and so this would basically create an array with 4 elements in it, right? And I could have said, it can be all integers, but I could have said it creates an array with 4 integers in it, but I'm just going to say elements because they can be all integers, but you can mix and match data types of elements in a list. Okay, so I really should be saying Python notation. So creates a list with 4 elements in it. Okay, and so hopefully that makes sense to you. And so now what we're going to do is we're going to try printing an element in the list. So now if we try to say print group of 0 minus group of 3, what is this going to do? It's going to try to take the elements at index positions 0 and 3 and subtract them. So it looks like group of 0 is 3 and group of 3 is 1. So it should be 3 minus 1 to get a 2, which is the last number, which is the only number that gets printed to the console. So that's essentially what we have going on with that. And then you can also go ahead and print the list. So now if you say print of group, you can go ahead and print an entire list. So this is capable, you can just say you can print a list. You can print an entire list. Okay, so it displays the list in square brackets with commas separating each of the elements, right? And then also you can reference elements by index position. So hopefully that's clear enough to you with what's going on. Okay, and then if you want to create an empty list, you would just obviously do it with square brackets, right? So you could say empty list is square brackets, and then you say print of empty list, right? And so this, we just created another list here, and so now that would just go ahead and print square brackets there. It turns out that a list can have multiple data types, and this is really a distinction to be drawn between Java and Python. Is that in Java, most of the time when we make data structures, we're usually looking for consistency and a sort of a homogeneity in our data types, and we want to be basically passing in similar objects. Python doesn't really care about that. So with Python, you can go ahead and have whatever types of items you want. So you could say items equals, and then we're going to go ahead and have some items in here. So what we're going to do is we're going to have a 10, we're going to have a -3, we're going to have the word pizza, we're going to go ahead and have a float, so let's do a 4.2, we're going to have the letter T, we're going to have a 1, and then we're basically going to have a Boolean. Okay, and so basically this would be looking at different data types. We've talked about 4 data types now, essentially. We've talked about an integer, we've talked about a float, which is like a decimal number. We talked about a string, which is basically a collection of characters. And now in the last video or two, we've talked about a Boolean. And so you can see that you can have all the data types in there. And so now if you say print of items, it's certainly capable enough to go ahead and print each of the items. And one of the things you'll realize is that if you have strings in your list, the way that they'll appear in the list on the console output is just with single quotations. So you can go ahead and realize that for yourself. And then if you have Booleans or if you have expressions of things, they would be evaluated before the list gets printed. So if you had, instead of saying 5 minus 3, what if you said 5? What if you, instead of saying -3, what if you said 5 minus 8? It's the same kind of deal, but I just want to show you that you can go ahead and see what would happen here. So now if you say, what if you said int of 1.8 instead of just 1? And then instead of false, what if you said true and false? So we know that that would evaluate to false. So now if you go ahead and print the list, you get the exact same output here. So hopefully that's clear to you, and that's what's going on. It turns out that actually one of the elements in your list can be a list, okay? So what you could do is you could say cool list, and then basically you could have a list of items, right? You could say that this is a list of items being one of the elements in the list of elements, right? So you could say 3, 2, and then you could say 5, and then you could say 1, 3, hey, okay, and then you could say false 2, 3. Okay, so this is just totally mixing and matching all the data types that we've been talking about. And you can see a couple of PEP suggestions, right? So we're getting a couple of annoying gray underlines. I'm guessing it's going to be a spacing issue. They probably want me to be spacing after the comments, right? So it's just a PEP thing. It's just saying, hey, you know, your code will be a little bit cleaner if you went ahead and did this. So it's no problem, right? And you can go ahead and do that. And then, so this is what you have here. So you basically have a list with 5 elements in it. 4 of those 5 elements are lists themselves, right? And then you just have this one integer hanging out as another element in your cool list, okay? And you could go ahead and print things. You could also index a particular index position of one of those inner lists. So if you said print cool list of 1, what would that print? Well, it would print these 2 elements. So it would print the 3 and the 2, because at index position 1, we have a list with those 2 integers in it. But what if you say print of cool list of 0 and 3? So now we would basically have 2 square brackets for 2 index positions. The first one would be looking at the index position within cool list, and then the second one would be looking at the index position within cool list of 0, because this element in the list is in and of itself a list. So then I guess you couldn't go up to the 3rd index position, but you could look at index position 2. So there you would go ahead and look to print items there. So hopefully that makes sense to you. And then you could also have a list of lists of lists, right? So that would be like list section, but you can go ahead and try that out on your own. And so if you have a list of lists, that could basically represent a 2-dimensional array, right? You could go ahead and just have numbers in here, right? Sort of like in linear algebra. I don't know how much math you guys are familiar with here, but you could see how a list of lists could be used to formulate something in linear algebra, right? And so then you have basically a set of vectors here. And so then if you want to look at one of the vectors, then you would go ahead and do that. So you'd say print matrix of 2, 0, right? And then it would go basically, I guess if you were thinking about it in rows, like 3, 4, 5, and then 8, 1, 3, and then 6, -6, -2, then this would go into row +2 technically, right? Which is really like the 3rd row. And then it'll go into column 0 technically, which is really like the 1st column. So there you'd be looking to print that 6. And that's exactly what we see printed on the console. It turns out that a string is a list of characters. So what you can actually do is you can actually index characters in a string the same way that you would access elements in a list. So let me show you what I mean by that. What we're going to do is we're going to say word equals watermelon. And then what we're going to do is we're going to say print word of 2. Okay, so word is not a list, but really it is, okay, because a string is a list of characters, and there we'll go ahead and print the T. So therefore, if we think of a string object as a list of characters, then it is no problem to access a character in a string, you know, by calling the index position as if the string were a list, right? So hopefully that makes sense to you, and that's basically what we have going on here, right? So then if you wanted the first element, remember we said that arrays start at index position 0. So then you would get the T for word of 2, and you would get the 0 for the W for word of 0, okay? We can also redefine values at any index position in a list. So if you're unhappy with one of the elements in a list, right, if you say list equals 3, 2, 3, and hey, and you say, you know what, I don't really want there to be a string hanging out in this list, right? And so what's the issue here? So it's a built-in lane, let's call it something else. You can call it my list, right? And then what you could do is you could say my list of 3 is going to be my list of 0 times my list of 1. So what would this do? It would take the elements at index positions 0 and 1, it would multiply them together, and it would put that result in index position 3. So then suddenly you would lose this hey, and then if you go ahead and say print of my list, hopefully you can sort of predict what we would get here. So now we would get 3, 2, 3, 6, because 3 times 2 is 6. We can also concatenate 2 lists together, doing basically either a scalar multiple of the list, or we can literally concatenate a list. So let me show you what I mean by that. If you have A equals 8 and 1 and 2, and B equals 2 and 3 and 2 and 7, okay, if you say basically print of A plus B, what this will do is basically this returns a list with all elements from A and B. Okay, duplicates are okay. So now if you go ahead and run this one, you would get 8, 1, 2, 2, 3, 2, 7. Okay, what if you said print of B times 2? So then you would just get 2 replications of the list B. So you'll get 2, 3, 2, 7, 2, 3, 2, 7. So hopefully that makes sense to you. It's basically just a way of concatenating a list, a way of combining a list with another list. What we can do is we can think about a Boolean that will return whether or not a element exists within the list. So I'm realizing that we're probably going to run out of time to talk about all of the things that we can do with lists. There are going to be some more methods that we're going to want to review in the next lesson. But what we can do is we can think about seeing whether or not a particular element exists within a list. And I think that's the last thing we're going to talk about today. So what we're going to do is we're going to go ahead and create a list, and we could go ahead and create some strings in it, right? So we could say something like August, and then we could say summer, and then we could say party, and then water skiing, sun, and then we can go ahead and say, how about barbecue? Okay, so like summer-like terms, right? And then, gee, what's the issue with water skiing here? So typo in the word water skiing. I don't think I spelled that wrong. Maybe Python doesn't know what water skiing is, but that's okay. So we would elect to ignore an error like that. But anyway, we have a list here. So what we can do is we can have a Boolean which will return true if and only if an element exists within a list. So for that, we use the keyword in. So let me show you what I mean. We're going to say print summer in X. So basically this is a Boolean that returns true if summer is an element in X. Okay, so hopefully we would expect that to return true because we do see summer in X. But what you have to realize is that the in keyword is case sensitive. Okay, so now if you go ahead and try to say print summer in X with all capital letters, then you might be able to predict that that would return false. Okay, the other thing that you could do is you could combine some things. So what you could do is you could say print not of winter in X, right? So now we're just talking again about combining these keywords, right? We said not just reverses the value of a Boolean expression. So now we would be asking if winter is not in X, and since winter is not in X, that's why we return true as the last Boolean down here. So hopefully that makes sense to you. And then we could have also said not in. So if you want to put the not, you can actually apply a not directly to an in. So we can use not to apply to an in Boolean, but not can also be applied directly to in. So basically that means you could also say print winter not in X, okay? And then you could combine that with another Boolean. You could say or false, okay? So the or false doesn't make a difference here. We said that if you combine a Boolean with or false, that doesn't affect anything. You would just evaluate the main Boolean, right? So you would say winter not in X or false, that would return true. But then if you say winter not in X and false, then that would return false. So hopefully that makes sense too. And then you can go ahead and pair these up however you see fit, right? So this is going to be a case sensitive. It's going to be a case sensitive. So just as a roadmap of going forward in a review of what we talked. So we talked about creating lists and remembering that we can access elements by index positions. And then we can also realize that we can have different data types can exist within the same list. We can have a list of lists, so nested lists. And then this requires us to specify 2 index positions if we're going to do that. And then we also, we can use the in keyword to check to see if an element belongs to a list, right? And then we can concatenate lists together. So we saw a couple of approaches to doing that. And then what else did we say here? So we also said, yeah, that there's an empty list, and that that's basically going to be the introduction here, because as we build more and more interesting programs, we want to learn the fundamentals. We want to learn everything that Python is capable of. So now that we've learned Booleans, and now that we understand lists, we're going to be going into a topic called loops, because once you have an understanding of lists, you can use a loop to get every element in the list. And you can see how these videos are going to be cumulative. And as long as you're following along and practicing these things on your own, hopefully these topics will make sense. So we're going to have one more lecture to talk about lists, one more lesson to kind of study the methods of it. And then we'll be talking about loops in the video after that, moving on to increasingly more interesting topics. So from you, Mills03, thanks for watching, and please subscribe.